Okay, today we're going to check to see whether a solution satisfies a differential equation. So we want to check that this y equals cosine of 4x divided by x satisfies this differential equation. X times y prime plus y equals to minus sine of 4x, and then they also want me to show that the initial condition is satisfied, so y evaluated at pi over 8 equals to 0. Okay, so the first thing we're going to do is we're going to take y and we're going to rewrite it as 1 over x times cosine of 4x. Then we're going to find y prime using the product rule, so when you take the derivative of 1 over x, we get minus 1 over x squared. And then we leave cosine of 4x alone. Then we do a plus and we leave 1 over x alone, and we take the derivative of cosine of 4x and we get minus 4 sine of 4x. Simplifying that, we get minus 1 over x squared cosine of 4x minus 4 sine of 4x divided by x. Alright, now we're going to plug this into y prime on the differential equation. So we have x, and then we're going to plug y prime, which is minus 1 over x squared cosine of 4x minus 4 sine of 4x divided by x, and then we're gonna add y, but y is just cosine of 4x divided by x, and we want to see if this is equals to minus sine of 4x. Getting rid of parentheses here, we get minus cosine of 4x divided by x, and then minus 4 sine of 4x plus cosine of 4x divided by x, and we want to see if this is equals to minus sine of 4x, and this cancels with that, so we get minus 4 sine of 4x equals to minus I think it was supposed to be a minus 4 here, otherwise it doesn't work, so minus 4 sine of 4x, and therefore the solution satisfies the differential equation. Now, does it satisfy the initial condition? We just have to plug in the pi over 8 everywhere you see x, and so that's cosine of 4 times pi over 8 divided by pi over 8, and this is cosine of pi over 2 divided by pi over 8, and that's obviously 0 because cosine of pi over 2 is 0. Alright, let's do another example. Let's see if this y equals x plus 1 minus 1/3 e to the x satisfies this differential equation, dy dx equals y minus x, and the initial condition y evaluated as 0, 2/3. In other words, we're going to see if this differential equation, if this solution satisfies the differential equation and the initial condition. And just like before, this time we have y, so we want to find dy, dx, and the derivative of x is equals to 1, and the derivative of, so minus 1/3, because the derivative of e to the x is e to the x, so that's what dy dx is equals to. So we want to find that dy dx is equals to y minus x, so we plug what dy dx is, that's 1 minus 1/3 e to the x, and on the other side we have y, which is x plus 1 minus 1/3 e to the x, that's what y is, and then we're subtracting x from it. And the idea is to see if the left hand side is equals to the right hand side on the differential equation by plugging in y and dy from the given solution. We get on this side 1 minus 1/3 e to the x, and on the other side we get the same thing, 1 minus 1/3 e to the x, because the x cancels with that x, so we get that. What about the initial condition? Y evaluated at 0 is equals to, we put 0 for x, 0 plus 1 on the solution, minus 1/3 times e to the 0, so that would be 1 minus 1/3, which is equals to 2/3. So satisfy the initial condition. Once again, I'm just verifying that a solution satisfies a differential equation. I'm not solving the differential equation, the solution is already given to me. Later on we're going to solve differential equations, but this time we're just checking that the solution is actually a solution. I don't know, let me see. Shall we do one more? Sure. We want to show that y equals c over x plus 2 is a solution to this differential equation dy dx equals to 1 over x times 2 minus y on the interval 0 to infinity. This is because x cannot be 0, so that's why it goes from 0 to infinity. Let's go ahead and find, it could go from minus infinity to 0, but over here they just wanted to see if it's true from 0 to infinity. So we need to find dy dx, and that's just equals to minus c over x squared. So plugging this into the differential equation, we get minus c over x squared, and we want to see if this is equals to 1 over x times 2 minus y, where y is c over x plus 2, like this. So let's see, minus c over x squared, is that going to be equals to, so we just multiply this out. Let's see, 1 over x, we take this 2 minus c over x, and then minus 2. The 2 and the 2 cancel. Minus c over x squared. Okay, so yeah, this is just minus c over x. The 2 and the 2 cancel like this. So we get minus c over x squared like this, equals to minus c over x squared. And there we have it. Okay, next time we're gonna do, I think it's called trigonometric integrals. Thank you.